am here to help you with any questions you might have while you're completing the calculations for the molar volume of a gas lab. So let's turn to our calculation section. So question number 1, it says convert the room temperature from Celsius to Kelvin. So in order to complete this one, we should remember that to calculate Kelvin, we're going to take our degrees Celsius and add 273. Question 2. Question 2 says Dalton's law of partial pressures states that the total pressure inside a container is the sum of all the partial pressures of each individual gas inside the container. So our total pressures equal to gas 1 plus gas 2 plus gas 3. So the entire point of putting your udiometer in the giant graduated cylinder was to help you equalize the pressure inside the tube with the pressure outside the tube. So this means that our pressure inside is going to be equal to our pressure outside. And so inside the udiometer, it says that we have both hydrogen gas and water vapor. So that means the P inside is the pressure of hydrogen plus the pressure of water vapor. And that's going to be equal to the total pressure outside, which is our barometric pressure, which should be in your data table. So we can find this number in our data table. Most likely, you're going to have this number already filled in your data table. And then what we're going to be doing is calculating the pressure of hydrogen. On number 3, we're going to calculate the number of moles of hydrogen gas that we produced. And we're going to use PV equals nRT, so the ideal gas law and the data we collected and the pressure of hydrogen. So let's think about P, V, N, and T for this one. So our pressure is going to be our pressure of hydrogen, which you just calculated in number 2. Our volume is going to be the number from our data table. And our number of moles, this is what we're trying to calculate, so I'm going to put a question mark there. And our temperature is going to be what you calculated in number 1. Remember when we use PV equals nRT, because of our value of R, we need to make sure everything is in the right unit. So we're going to plug all of those numbers into PV equals nRT, and we're going to solve for our moles. For number 4, we want to calculate the volume of hydrogen now at STP. And in order to do this, we're going to use the combined gas law. Remember, the combined gas law formula is P1 V1 for N1 T1, that's going to equal P2 V2 over N2 T2. And when we calculate this, we got to think about what each of our values are. So we're going to think about P, V, N, and T. So our initial conditions are going to be the ones that we measured during our labs. We can call these like our initial over here. And so our pressure that we measured in the lab is going to be what we calculated in number 2 for our pressure of hydrogen. The volume is going to be, again, the volume of hydrogen from our data. Our N, if you want to, you can use the value that you calculated in number 3. And for T, we're going to calculate what you got for number 1. And what we're going to do is we're going to set those equal to some final conditions. And our final conditions are going to be at STP. So think about what the pressure is at STP. You should know that. The volume is what you're going to try to be calculating. Our N, we actually are not going to change our number of moles in this, so it's number 3. same as our initial. So if you want, you can just exclude this from our combined gas law. And then our T is going to be our STP temperature. So you should know what that is to fill that in. And that should help you fill in the combined gas law as we mentioned up here. Okay, let's move on to number 5. For number 5, what we want to do is we want to find the volume of 1 mole of hydrogen gas at STP. But this is going to be according to your data, okay? So not our expected value. And remember, our unit is going to be liters per mole. So if you think about the past couple problems that we've done, in number 4, your final answer should have been a volume in liters. So what we can do is we can take our answer from number 4, and then to get the per mole part, up here on number 3, we should have gotten an answer in moles. And so we can put that on the bottom. And so we're going to get our answer from 4 divided by our answer from 3, and that should get you your answer to number 5. So now let's do our conclusions and our questions. Number 1 is asking us to calculate our percent error for the experiment. And what we're going to do first is we're going to use our molar volume of a gas, okay? Now remember, our theoretical is going to be 22.4 liters per mole. So we're going to plug 22.4 in for right here. And then the calculation you just completed on number 5 is going to be our experimental value. And in order to get credit for this one, make sure that you are showing all your math for full credit. Just having an answer here won't get you any credit. Now we are going to use the data that you have collected throughout the lab, which is the mass of magnesium and the temperature and some other things, in order to calculate the theoretical volume of hydrogen gas that should have been produced. So anytime we think should have been produced, this is going to be our theoretical. So in order to start this, you're going to begin with the mass of magnesium. And what we're trying to get to is the volume of hydrogen. So if you think about our mole island, you're starting with grams, and we want to get to a volume of hydrogen. And so in order to do that, we need to convert to moles of magnesium, and then to moles of hydrogen. And then we're going to convert to liters of hydrogen. So think about all the ways that help us get there. So we're going to use molar mass, we'll use a mole ratio, and then because we are not at STP, we'll have to use a different method at the end. So we'll convert from grams to moles of magnesium to moles of hydrogen. And since we're not at STP, for this last step, we're going to have to use PV equals nRT. So we will use Pivnert. And this moles of hydrogen that we get here, we're going to plug in for moles. For P, we're going to use the answer from the first number 2, not this number 2, the first number 2. Volume is what we're trying to calculate. We know the value of R, and the T is going to be the number you calculated in the first number 1, not this number 1. And then this is going to give you, remember, an answer with a unit of volume. So make sure you remember your unit. Then we're going to calculate our percent error, but now based off of volume, unlike number 1 where we did it with our molar volume. So we're still going to use that same equation from up here. And this time our theoretical is going to be what we just calculated in number 2, this number 2. And our experimental is from our data, and it's the volume of hydrogen gas from our data. And just make sure that your units match. For our last question, it's going to be about an error that you might have had. So if you remember, after your reaction was done reacting, we had our eudiometer, and you had like a level here of gas versus liquid. And before you put it in the giant graduated cylinder to measure, there were a lot of gas bubbles down here. And what you were supposed to do is you were supposed to tap, 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 so that hopefully these gas bubbles ended up here. So this, right, was our hydrogen. And so if you had not tap, tap, tapped, and the water bubble, the gas was still stuck at the bottom of the eudiometer, then would your measure volume of your hydrogen be too high or too low? And make sure you explain.